So today we are going to do some comparison operators, loops, and maybe we're going a bit in detail into lists. So comparison operators are like the mathematical comparison operators. So less than, greater, equal, or unequal. And these comparison operators do lead into Boolean types, which we showed last lecture. These are either true or false. So if the comparison operators, if one is bigger than 2, this is true, otherwise it's false. But you have to compare comparable expressions, so they need to have a type which is comparable. This means you can compare numbers, you can compare integers and floats, but you cannot compare integers and strings because they are not comparable. Yeah, as I mentioned, let's see. The exercise starts at, oh, I'm sure. Martin, do you know? ST or CT? We didn't. I think ST, no? Martin?
I think, yeah, I think we are free to use. So at university, normally we use, yeah, CT. So let's use CT simply.
Okay.
No need to change something.
Okay, so CT. So now here we have some comparison operators, and if you'd like to see, these are pretty similar to the mathematical comparison operators. So if you have two variables or two expressions, for example, we have numbers. So I bigger than j, this means that you become true if I is bigger than j. So if we have numbers, for example, and we say 5 is bigger than 2, this is true. So, but if we say 5 is bigger than 10, we have false. And it's the same exact way for greater or equal. So if something is greater or equal to, you have true. But if you do want to compare 5, you become also true. But afterwards, this is false. So if you say 5 greater or equal to 6, this is false. And that's the exact way in the other way around. So if you compare less than, so y less than j, I don't think we have to go too big into detail about this. I think it's clear. So if you say 6 is less than 2, this is false. But if you say 6 is less than 10, this is true, on the other way around. Then you can also compare to equality. So if 5 equals 5, this is true, and if something else, this is false, and the other way around. So if you want to compare to unequal, this is true if it's unequal, and not true. So if you the same example, I have to look over my monitor. We have false, but because 5 is unequal, 5 is equal to 5, so it's false. But if we say unequal 5, unequal 1, this leads into true. And so this is, I have to, we can make another short break. So if you think it's helpful, I'm not sure. Did someone participated, or did we offer the link?
Yeah, we offered a link and we have not so many votes currently. We have the most say yes to practice and 4 say yes for both, and 3 people say no, they don't need any breaks. Yeah, currently it's changing. Let's come back to this later.
Okay. But so I think we make a short break, and not too long, say 3 minutes or 2 minutes could be enough. And for those who don't need a break, you can make you some coffee or something else. Then let's say so 2 minutes, that's enough. I think the comparison operators are not that complex. It's getting a bit more complex, but this is pretty simple. Yes, if you want to prove for equality, you have to write down two equal signs. So one equal sign, as you said, is for assigning variables. So if you write 1 to 3, this becomes an error because 1 cannot be a variable where you can save another value in it. So you have to then say x equals 3, which is possible, but if you want to check for equality, you have to write down these double equal signs. The attendance for the access courses is optional. The only thing which is mandatory are the exercise sheets, but if you're fine, if you're good in just finishing these ones without any help, that's totally fine. So you don't have to attend in an exercise course. That's for those who need a little bit help, have questions, but also the exercise sheets will be discussed. Today, the first exercise sheet will be discussed, next week the next one, and so on. But you don't have to attend if you don't want to. Okay, I think we can go on. You can make much more complex expressions out of these, so you don't have to just check about one thing. You can also, to simplify something, you can check if 1 is less. So you can combine them if you want to. So you can 1 is less than 2, is less than 3, is less than 4. So this is also a possibility. But if you then write 1 is less than 2, is greater than 3, this is false because 3 is greater than 2, of course. So you can make much more complex expressions out of these. So you can use brackets to combine them as well. But we do this, yeah, we can later on this. In the next slides, we're combining these with brackets. But you can also compare strings. So I think you can. This makes it a little bit more fun to try this out. So we make another 2 minutes after this. So strings can also be compared together, and they are compared in lexicographical order. This is called. So this means we go stepwise through these conditions, which says, okay, letter. So strings go character by character through the string. So if we have a string, I'm pretty uncreative, Tom, and we want to check if this is less or equal than Martin. We have to go character by character through this string. So see what comes out. This is false because Tom is greater than Martin because T, okay, yeah, because T comes before M in the alphabet. This means if you want to check for say, make an example about only one letter, A and Z. So A is is less than Z because it comes in the alphabet before Z. So everything which is before. But if you have the same letters, the capital letter is less than the lower letter. This means you then have, if you want to, so let's make this example again, but now we want to check Tom and Tom. We do compare these two characters, and if you then want to check, this is false because the capital T is less than the lower T. So if you can make another example from the sheet, so capital A is less than the lower A, the lower letter A. If you then have the string which is pretty in common with the other one, the shorter string is less than the other one. So we have, let's go forward with this example. So now these strings are pretty equal, but we have Tommy. So we do now have that Tom is less than Tommy because Tom finishes here and Tommy goes on with the my at the end. But if we do now try to compare these two strings, and we make another this capital letter, this is false because we go stepwise through the string. This means that we do firstly compare the lower t, sorry, with the capital T. This means then it's finished. So after this goes through these conditions, and the condition which is met firstly will then come out with the true or false. So I think this is a little bit more complex. So if you want to, or we can also make two strings which are equal. I didn't show strings which are equal. So if you have the exact same string and want to know if they are equal, these are equal. So what you can do now is try to use some strings, try to compare someone, because I think it's not that easy to determine what happens if you compare two strings. Now let's say another 2 or 3 minutes. That should be enough. Martin, yes, that's behind. That's the magic behind this. So ASCII for the other ones are the codes from the computer. These are numbers which have, is this a hash? Oh, I'm not sure. But these are some encodings for the strings, so that the computer knows that there's a letter instead of a number. This is the representation behind the characters.
By looking at the poll, most of the people like breaks. So a large majority says they like breaks for both or simply to practice.
Perfect, me too. I like breaks too. If a sentence as a string, if you have a sentence, this is the exact same way. So if you say hello, my name is. But right now I'm not sure how the space is counted. So, but we can try. So let's have a look how spaces are compared. That means when we do write this without any space. Okay, a space is less than a letter. We see now. So we do now have exactly the same string as sentence. This is no sentence, but there will be the hellos compared character by character, and it's totally equal. So, but after this, we have to compare the space between the my and the m from here. So the space is obviously less than the m. But if you have it now another sentence, which is a real sentence, you can do also hello there. You can also compare these ones with this. So at this time, this string is exactly the same, including the space, but the t is greater than the m. So this is true because then the space is the m is less than t. But it works exactly the same way like normal strings without any spaces in between. Wait, let me copy this. This goes into false because you did write a capital I here and a lower letter I there. So if you do now, while it's this way around, you have the capital C there. So this is, I think this might be a typo in your sentence, because if you have a lower letter here, this one is compared stepwise. So the first word which is compared is the I with the I, and this is a capital letter I, and capital letters are less than lower letters. So this is false in this way. But if you then have exact way this around, you do then have to check the capital C with the lower letter C, and then it is true, because this one is less than instead. So, any other questions, or should we go on? Well, we can wait until one more minute. Okay, let's go on with some. So next one are logic operators. These logic operators do combine statements which are true or false. So you can then say and, or, and not. This means you have to combine two expressions which are true or false. So if you say true and true, this is true. But if you say true and false, this leads into false. So this means if you have so let's use this one, because these comparisons lead into booleans. So we have Tom equals Tom is true, and now we can use these brackets to show that we do firstly evaluate these expressions here, and if we do now want to combine this with the AND operator, we want to say that both conditions have to be true, so that this leads into another true boolean. So if we say then 1 is less than 2, these both expressions lead into true, and we then become true again. But if one of these expressions are false, so if we say 1 is greater than 2, this leads into false. So for the AND operator, all expressions need to be true. And the other operator is the OR. For the OR, it's enough if one of these expressions are true. This means if we have the same example and say OR, we have now Tom equals Tom, which is true, and 1 is greater than 2, which is false. But with the OR statement, it's enough if one of these are true. So this example does only fit into a false if both are false. This means if you say, okay, Tom is unequal to Tom and 1 is greater than 2, we become false. So, but because both of them are false and there's no other chance for this. But it's also true if both are true. This means if we do this correct now, let's say Tom equals Tom, and we have another OR 1 is less than 2, we do also lead into true, same way as like with the AND. And the NOT operator does negate your statement. This means if we have now, so let's make this a little bit more complex. We do now have another bracket and the NOT comparator. So in this example, we have 3 brackets, and the most inner brackets are evaluated firstly. This means this bracket and this bracket are on the same level. This means at first these two are evaluated. This means Tom equals Tom, then 1 is less than 2. So we have true, true, and then the expression comes into this OR. So we then want to try, okay, true or true. And then after this this happened, we then evaluate this with not. So we come out into false because Tom equals Tom or 1 is less than 2 is true, but the not negates the same thing. So on the other way around, if we have unequal, and let's say now we have an and again, and with the end, as I mentioned before, if one of these two are false, the statement is false. So now we have false and true, which is false, but not. This means we have true instead. So I can try to write this the other way. I think it maybe comes a little bit more clear. I'm not sure. So write this way. I think I try to show what I mean with true and false. So we have Tom unequals Tom, which is false. So this is the exact thing what happens if we evaluate the statements, we become false. And if we evaluate this statement, we become true. So the exact same thing like here. And then we try to evaluate this statement, which is false and true, what leads into false. But yeah, we do negate this one. So we have true again. On the other step, so if we break down this completely, we have this one. Because false and true is false, so we have here this false, and then we do only write not in front of it and become true. So this can be more and more complex. So I think you will now have 5 minutes to try something out and ask questions, but because I think this is not that intuitive. So not A is true, not A is true as long as A is false. Yeah, right, exactly. I can show you on the next slide a little bit more detail while you're making some fancy stuff on your own. If you have not A and A is true, like here, so you become false. So every time A is false, not A is true, and the other way around. How will be the exercise class and the time? The exercise course will be today, the first one, from 2 to 4. And the next one will be Thursday from 4 to 6. But the Thursday class is a little bit more for the EdTech students, and you can choose which one of the slots you want to participate in, but you don't have to if you don't want. So it's not mandatory to join the exercise courses, but you can if you want to, if you need help or if you want to discuss the exercise sheet before. So today the first exercise sheet will be discussed next week, the next Excel sheet will be discussed, but you have also time to ask some questions about the current exercise sheet. Not able to enroll for this course on Moodle now is very helpful because I think I have not been enrolled. I think this must be possible already to enroll for this course. I think we did not close we did not close the course, so I think you have to enroll for it. You can.
Yeah, the enrollment is open.
And you can finish the course successfully as well, because I think if you did not enroll until today or right now, you then have to do the last exercise sheet, so the 6th one after the holidays, and this will be enough. So you can also successfully finish this course if you want to. Okay, do you have some questions about logic operators? There were some progress. But for Martin, for you it works right now, or do you have any problems at all? Because in the Moodle platform there was a bug, so we saw only one participant for the course at this time, but right now everything's fine. So I think everything should be fine as well. Okay, but if you don't have any question about this, I think we can go on. I have some other examples if you want to have some other examples, but at the end of the course, if you do have questions of this lecture today, if you have more questions about this one, we can go more in detail with this, or we have there some examples, so you can look about this afterwards. Very good. You can go through the lecture afterwards and watch some examples if you want to with these ones. I think we made enough at this time, but we can, if you want to just call it out, we can make some more examples. But for now, I want to introduce the if statement. And the if statement uses these conditions, which are true or false. This looks like a little bit confusing, but we're going through this step by step. So for the if condition, if statement, we have conditions to check. So this means if something is true, we want to evaluate the expression which is below the if statement, so on the left-hand side. For example, if we want to say we have x equals 5, or no, let's say x equals 10. And we want to check if x is greater than and we want to print out that x is positive. So in this example, we have our variable x, which is 10 right now, and we then want to check with our comparison operator if x is greater than 0. So and if this condition is true, we want to evaluate this one. So we want then to print out that x is positive. This is what you also have to keep in mind. In Python, you don't have brackets to close some statements. You need to indent this one, so this like a tab or something. So in Jupyter Notebook, if you make a new line, this is made automatically, but not in every. I think not in every development environment. So keep in mind you have to write this down this way. So Python knows which blocks belong together. So because if you write this in this one and say print x itself, this is evaluated as without any. It doesn't matter if there's an if or not, and if it's true or not. This is be printed out elsewhere. So if x is 10 and this is true, but if this false, the other way around, this will be printed out. So, but what you saw right now is that if this statement is false, nothing happens. So this will be skipped because this is false. And for this reason, we have, we have to then, if the condition is true, we need to evaluate this one. So this print on the left-hand side is the same thing like the expression. So the expression is a little bit more general. And this is a little bit more in practice, because we cannot simply write expression, nothing happens. This is false. Become linear syntax error. Okay, but if this one is false, we can choose to say, okay, else there will happen some other things. And then the next expression will be evaluated. So if you say, let's make a new example with the same, and we want to say else, then keep in mind that this this one we have not to indent the else, so it's the same level like the if statements. And we don't have any statement here, because if this is false, we do evaluate this expression no matter what. So we then can print, because we know that x is not positive. We can say, so now x is minus 10, so x is not greater than 0, and x is not positive. But if we have x is 10 again, x is positive, because this one is true, and if this one is evaluated, the else block will be skipped at this time. What we can also introduce is another proof of a condition, the elif. Sounds a little bit weird, but we can say if our if statement is false, we can then make another condition, say elif, and have to make another one, say x is less than 0. We can print out is negative. And then we also know at this point, at this else, that x is 0, because if both are false, we know x has to be 0. So right now we evaluate first x is greater than 0, so x is positive. On the other way around, if x is minus 10, this is false, and this will be skipped, but the other next condition will be proved. So x is less than 0, which is true, so x is negative. So we become then x is negative. So if we do then choose to say x is 0, both of them are false, then the else statement will be swanning the expression. But you don't have to, you can do more elifs if you want. You can make as much elifs. There's no border in this, so you can make many more elifs. So for a new example, we can say we want to check if x is one of the following numbers. So if x is 1, we do the first thing, say x equals. I'm not sure how much sense this example made, but it's only to show you how often you can use elifs. So you can then say, let's make another elif. Not this way. And let's make another elif. So you can make as much as you want. This is what I'm trying to say. So you can then check if x equals 3 or x equals something else. 3 and 4. And at the end, if none of these conditions are met anywhere, one moment, you say x is something else. So at this example, we have x equals 3. So we do firstly check if x is assigned to 3. Sorry. So we can then check if x equals 1, which is false. We check if x equals 2, which is false. But we then check if x equals 3, and we then hit this print statement and say x equals 3. But if x is 5, for example, we don't even met one of these conditions, and we then have to evaluate the else statement, say x is something else. This will also happen if you say x is minus 155. So this happens for every value, which is not 1, 2, 3, or 4. But if you want to, you can go on with this list with these elifs. You can be creative if you want to. How many sense this makes, I'm not sure many times, but it can be helpful. Okay, one question I think, as there has to be said there every time the colon. Yes, you need to have this colon. So if you leave this out, you become a syntax error, because Python then knows that something comes afterwards. So you do always need these columns. Okay, I think we can now make another. How much time is it? 10. Yeah, we have time. Let's say until 9:15. Let's have about 5 minutes where you can try this out. This can be very complex, so you can combine much conditions, much if and else statements, or just leave it. I think you can also leave the else statement here out, so that nothing happens. So you can make much more things if you want to. And the else statement is for something to say, if no condition is met, else make this one. But you can also ignore this else statement and say, okay, nothing happens if these conditions are not met. And in this example, if we leave the else statement out, we have the minus 155, nothing is met, and so nothing happens in this way around. But it can be helpful to have an else statement so that you know at least that x is something else. Okay. Let's say have another three or 4 minutes. But if you think it's too complex, we can try to make other examples, or maybe at the end of the lecture if you have. I can put colons as or just. What do you mean exactly? You can use brackets. You cannot use this brackets. I'm not sure how these are called. This ones you cannot use because this is for another data type. But you can of course use these brackets, but you don't have to. In Python, this is not. You don't have to use brackets, but you can if you want. Brackets don't even bother this at all. So this works fine if you use these ones. I'm unsure if you can then leave out. No, you cannot leave out the colon instead of these brackets. But you can leave out the brackets. I'm not sure if I answered your question right. Okay, do you have any specific questions, or do you have some misunderstandings? Do you want to have some more examples of these statements? So do you think it's clear how if works and how these elifs and else statements work? Okay, I think then we can go on with loops. Loops are, it gets a little bit more complex right now. So the whole lecture, I think you see is a little bit more complex. So for loops stands for that you do something more often than once for a sequence of values or something else. So in a for loop, you have a variable which you assign to different values from a sequence, and you iterate stepwise over the sequence. So to iterate means that you do go through a sequence step by step. I can show this one. So we have for example, x in, what is 11? Okay, before we go into the for loops, let's answer questions about the if statement. Elif is nearly like an if. Elif is what happens or what will be proved after the if statement is false. So you can say if x is greater than 0. No, it's not. Elif, okay. What is then? So x is less than 0, so you can prove this one the other way around. But what you can also do if you don't want to make these elifs the whole time, let's say you can only let's say just instead make another if instead of the elif. But then keep in mind, so this will have the exact same outcome like this one, this example. This means we have 5, so x is positive, and if x is -5, you have x is negative. But at this time, both of these conditions are proved. And if you do not want to prove every time the same condition, but because sometimes this doesn't make any sense, you use this elif and say, if this condition is not met, okay, I will prove the next one. But at this example, you prove both conditions no matter what. This means if this one is true, this example, you will also you will not skip this condition. So you will do to prove this no matter what. So then it can make much more sense to use this elif statement if you want to combine some conditions. Because here you will prove both conditions no matter what happens. If this is true, you will prove this condition. If this is false, you will prove this condition. But if this condition over there is true, you will print x is positive and you will skip the rest of this. And this is not the case in this example here. Okay, but if you have another questions about to ask every time, we can go further. But now for loops. So we have for x in. Let's make a sequence. This one you didn't saw this this data type right now, but this is a list. Maybe we'll go on next. No, maybe at the end of the lecture. This depends on how much time we have left. So we can then say 1, 2, 3, 4, 5. This is a list of 5 values. We have 1, 2, 3, 4, and 5. And in this for loop, you will assign to x every member of the sequence. This means if we then want to just print x out to show what x is, we have to print 1, 2, 3, 4, and 5. Because x, we go through the sequence. We have 1, 2, 3, 4, 5 rounds, if you want to say it this way. And x is one of these elements for every round. So we go stepwise through the sequence and print our x. This is for if you want to, iterate over a list or over a sequence. So you can also do this with a string. A string is also a sequence. A string is a sequence of characters. So if you want to say x in, oh, I don't know, hello again, then x becomes a character each time for every round of this. So if you then print x again, you will become the character every time you go through this. And after this print, you have a new line, and this becomes this way. So, but what I didn't mention before, you cannot change things you're iterating over. This is you will. I think you will see later on becomes a little bit more important, but you cannot change, for example, the sequence while you're iterating over it, or while you are using the for loop, because you then do modify the list, and this is not what Python wants you to do. I'm not sure why this is the case, but this is so. You have to live with this. You can now try to use this for loop. What you can try with the for loop, instead of printing something out, if you want to, you can try to do the same. But if you want to do something a little bit different, you can try to reverse a string. So let's say you become a string called, again, you can choose everything you want, but a string where you can see that you reverse it afterwards, not use the string Anna or something like this. If you say hello, you want then afterwards, after this for loop, that the string is called OL. Just try to use a for loop to reverse the string this way around. I think you will become another 3 to 4 minutes, and then let's try to program it and show the solution. It's pretty bright in my room. This is possible. Hello again. I'm not sure. As this works. I noticed this works. But I haven't done this before. You mean after while using a for loop? No, I think if you just predict to have this in one line, but I think you mean in a for loop. So for x in. But in a for loop, let me think about. Let's see again. This one? No. But this work. I'm sure there is. You can write something other. I think you have to write something other than this print statement or modify it. But right now I'm not sure how. I need to look it up.
There is a different command.
Yes, right.
So print always makes a break at the end of a character.
But yeah, but there's a modification of this print statement, right? Where you can where you do not have this new line at the end. But right now I'm not sure which one it is. I don't know. Do we have some? I want to.
You can put the end parameter to space.
Sorry?
You can put the parameter end to space and print.
Where exactly?
Print x and then comma inside here.
Oh.
And equals space.
Thank you. So there is okay, but with another suggestion from Martin that you can always also do this one. I'm not sure if this works, but let's try it out. No, this works. This does not work. You think because it's. I think to reverse the string because okay yeah, this was from the first Excel sheet, but you can do this also with for loop, which is a little bit more work. What means work, but let's do it. So we have x equals hello. Reverse this with a for loop. We can write. You have another string, let's say which we want to reverse, which is empty. I'm doing nonsense. So for x in hello, we can then simply say string2 equals x plus string2. So we do assign the first character to the last character to the first index of this hello, and if we then print our string true, we hopefully get the other way around. So this one is pretty much more easier, and you can do this as you want, but this is the example how you can do this with a for statement. Okay, do you have any questions about for statements? Because they can become very complex even if you have more for statements. Because you can have nested for statements. So maybe at the end of this lecture I can show you a little bit more complex for statements or while loops, which we are going to do. Not done. We can. Yeah, we have the range functions. Another one to make this to make some sequences of numbers The range function is also implemented in Python native. You can use this one to make sequences of numbers, how you want to do this. So if you have default values, so you don't have to always set these numbers. And you have default values to start. So you have range, a function which starts with a value, which stops after it reaches a value, and a step. So a step says how far you go for every step. And by default, you have step equals 1 and start equals 0. So if you do only write range 10, so if we do this, we can do this pretty good in a for statement, for example, and say range 10. We do become again the range until from 0 to 9, I think. Should be, what have I done? We become again from 0 to 9, which, like we said, we saw last lecture, the 10 is excluded. So we always have this 0 and the 10 is excluded. And also, if you want to set a start value from this number, if we say 4, the 4 is included again and the 10 is excluded. So we have then 4 to 9 if you want to start at another value. And we can also choose to make other steps. So we don't have to make steps 1, 5, 6, 7, 8, 9. We can also say how far we go after each step. For example, 2, and we become 4, 6, and 8. So we start with 4, go 2 steps, have 6, go 2 steps, have 8, go 2 steps, have 10, which is excluded. So we finished after this one. But you can also make the same things in the other way around. So if we start with -4 and we go to -10 and our steps are -2, we go the other way around. So into the negative, and we become -4, -6, and -8. So this is another example where you can use, let's say, sequences of numbers for your for statement, for example. It makes it a little bit more easier to, afterwards you have to just type these whole numbers. So then you can say, if you want to make a huge number, what is this? To make a huge number, you have 100, for example, and print this out, we become every number from 0 to 99. Okay, that's so much about this. We do not go into much detail about the range function. I think you will explore it maybe by yourself, maybe not. But the next one is a while loop, which is also pretty important. And while loop, other than the for loop, in a while loop you make your you express your code below the while as long as a condition is met. This means we have, like in the for if statement, a condition which needs to be true. So if we say, let's try to type. So we have, for example, our x again equals 0, and while our x is less than 10, for example, we can then say again print our x. It's a little bit uncreative, but I think it's it explains the way good enough. So for this while loop, we do print x as long as x is less than 10. And x is now 0 at the start of this, so 0 is less than 10, which is true. So we go through this loop, print x out, and then we assign x to x plus 1. So to make it visible near x plus 1. So this is the same notation, but I think it's a little bit more clearer this way. And then x is 1, so x is also less than 10, x is printed out. And this goes on until x equals 10, and then x is equal to 10, so this is false. And after this while loop condition gets false, we break out. This means we then only do print out the values from 0 to 9, because after x is equal to 10, yeah, we skip this one. And it makes a difference if we print our x here before this one and after this one, because after this one we start with 1 and print the numbers to 10 because x is also printed out, and before we do add 1 to x after we printed x out, and now we make this even before. Okay, every number except 0 is true. This means that we can make another thing. So for a while loop, either we have false, something to come out with a false, or we do have 0. 0 is false as well. So if we have x is 10, for example, and say while x and x minus 1, we do subtract 1 from x, and as long as x is not 0, we will print this out. So after x reaches 0, this is false, and yeah, we print 0 at the end, and then x is 0 and 0 is equal to false, for example. If you want to, I would like to see bigger screen share. Oh, I can let me look. Is this better? I cannot make the presentation zoom in to the presentation, but I can zoom in into the Jupyter Notebook. Okay. What we can also do in a while statement. Yeah, we prove this proofs condition, and until this condition is true, we are doing some stuff, and when it's false, we break out. And after we can also break out even before something is met with a break statement. This means that this break statement breaks out of a loop after something happened. So for example, if you have the same exact example and want to break out even earlier, we can then check if x equals 5, for example, and if this is the case, we break out. This means that a break statement is able to break out of a loop after something is met or something else. So at this point, we do only print out until x equals 5, and when x equals 5, we break out of this while loop because we use this break. And what you see on the right example with this while loop, these are two while loops, which is also possible, which is not uncommon to use. After a condition is met here, and after we made an expression here, we break out of this while loop and go on with the while loop before. And what happens then is we do not anymore do evaluate this expression. We skip this expression because it comes after this break from this inner while loop, and we go on with the next expression from the outer while loop in this way around. So here we don't have an outer while loop, so we do only skip this while loop and are finished after this. You can also do this with inside a for statement. So if we use a for statement, this long. So if we use this for statement and we want to say if x, I always use brackets, if x is 20, for example, we want to break out. So after this, we do only print out these 21 values, but after x equals 20, we break out of this. In this function, x has the range function with the sequence of numbers 0 to 99. We have only one step as a default value. So this one is the same thing as we write down 1 and 0 101. So these are the default values. So we start with 0, we stop at excluded 100, so 99, and we go just one step after this. And if x equals 20, we break out of this statement. Okay, this can be pretty complex. If you want to, we have 20 minutes left. I want to introduce lists with you today, but only high level. So you can have 5 more minutes if you want to use something out, to ask some questions if you want. Yeah, let's have a short break, about 4 minutes. Okay, one moment. What is the difference of while and for loop? I think I can explain you right after this slide a little bit more detailed. But the main difference is, in a for loop, you iterate over a given sequence. So your value, your variable becomes another one from the statement, for sequence, sorry. In a while loop, you prove a condition if something is true or false. So for a for loop, you end after a number of iterations from the sequence, and in a while loop, you end after some condition is not met or is wrong. And in the if statement and the while statement, I can use a elif statement. One moment. So if we have this one, like do you mean it's after this if statement, or do you mean at the beginning of this one? Because this is not possible because you didn't prove a condition before, but for sure you can say if x equals 9, break 5 is also well. After this one, you can prove if, as long as x is less than 3, for example, let's say print out x 3. So no, we do a moment. Let's say make it the other way around again, and sum it up. So in this case, we do print out x as we did it always, and you sum 1 to x up. So after you then prove this statement, and if x equals 5, you break out of this while loop, and if this is wrong, you prove the next one. Say if x is less than 3, This means we start with 0, go down to 1, 2, 3, 4, 5, and the first 3 times we print out x is less than 3 for 0, 1 and 2. I can execute this one. So we skip the 0 at this point because we do to sum it up with 1. So we have x is 1 at this place, x is unequal to 5, so we do not break. And because this is wrong, false, sorry, we prove if x is less than 3, x is less than 3 because 1 is less than 3, we print out x is less than 3. But then it is true, it's the same way. After x is 3 then, so because we summed up 1 every time, we print 3, and x is also false. The if statement is also false, so we do not break at this point, and the elif is false as well because x is 3 right now, so we skip this statement as well, so we do not no longer print x is less than 3 out. So you can use this elif as you want to, but for this if statement, if you do break here, you don't break out of this if statement, you break out of the loop instead. Between if and break. Okay, okay, okay. Yes, I think between if and break. Okay, okay. Okay, so far let's go a little bit on now because it's so to explain the question before, what's the difference between a for and a while loop is in a while loop you have a known number of iterations because the sequence is known. It says there's an absolute number how long this one is. In a while loop you may have an unbounded number of iterations because you try to check about something else. You don't have to use it with only with numbers and say +1. There are other examples where you don't have to do this, and this can go much longer. For example, if we can example after this. I think in the exercise sheet 2 there's an example about this where you have to do this with a while loop. Yes, so for loop you have a known number of iterations. You can end both via break, as we saw before. The for loop uses a counter. So your counter instead is that you count how often you go through the sequence. And a while loop can use a counter, but this counter has to be initialized, like this one. This is your counter at this place. So we count up until we reach 10, and then we go out. Not in this example because we break, but this is our counter in this example. And what's another difference is that you may not be able to write a while loop using a for loop, because if you're using a for loop, you have a known number of iterations, and while using a while loop, you don't have to end after a things number. Oh, I don't know the word. After an absolute number. But in a while loop, you can rewrite a for loop as well, as we did here. So here we can, if we want to, we can make a for loop out of this, but not in some times, not the other way around. Okay, then now. Okay, we do now go on to lists, but I want to show you an example where you don't have to use numbers like in a for loop, because this is nearly pretty similar to for loops. What we can do as well is to check for, in a while loop, to check this. Firstly, we have x equals an empty string, and we go through a while loop until x, as long as x is unequal to exit. Then we want to say, okay, x equals input type something, and then we print x again, as we do this always. So right now we are in a while loop where we don't have a bounded number of iterations. We can now choose from ourselves if we want to skip out. So if we use this, we have to input a string. We say hello, and then again. So this once as long as we type exit in it. So we can type anything we want, and this is printed out. We can type 10 because this is not 10. This is a string 10, and this will print it out until we type exit. After this one, we're finished because x equals exit, and this is then it is false, and we break out of this one. This is another example of what you cannot do with a for loop. In a while loop, you can do some stuff like this, but not in a for loop. Okay, we have 10 minutes left, but we want to introduce lists as well. It's a little bit complex, but I think you can cope with it. Lists are a group of data. So as we saw before, the sequence, you write lists down like this. So we have a list, let's call it L, and this is with these brackets, and this is a sequence of different elements. So you don't have to write only numbers or only strings. You can write one, hello. You can even write another list in it if you want to, but I think this becomes too complex right now. But you can write anything else if you want. You can also write some floats in it, for example, 5.0, and we then have a list if you want to look how this list looks like. We have this one, for example. Lists are also like strings, 0 index. So you start with 0. So if you have a list at place 0, you become 1. And so you have to write the length of the list -1 is 0, 1, 2, 3 to become the last element of it. So if you write 4, you have an index out of bounds, and this exception you don't want to have. So let's clean this up. But you can also use the slicing method, like for strings, and the concatenation operator. This means if you have your list and say, okay, your list is now list plus another 10, and you don't want to see what this looks like, you can add elements to your list. But other than strings, lists are mutable. This means that if you really want to, you can say list at place 0 equals 999, for example. And then if you don't want to know how to look the list, you can have then changed your 1 to 99. This can be pretty helpful in much sequences and much lists of operations. So here we have nearly the exact same thing. Let's write this one down. So we have 1 equals I. Then we have 5 and 4. But what I've shown before, you can also use the negative index for them. So if you want to know what's at -2, then we become 5, because we start with -1 here and have -2 at this place. Okay, these are the simplest. This is nearly the same like for strings. Like here, it's also nearly the same, but you can modify lists, and you can also access sublists. So if you want to have another list, which is a sublist of your first list, you then write down something like this and say, I want my list starting at index 1. Or to, or let's not say -1, let's say 3, and 3 is 1. This must be this one, right? This it looks like this is by and 5. So because we start with 1 at this index and 3 is excluded at this point, and we have 5. This is nearly the same like for the string operations. Okay, but you can also concatenate lists as well, as I shown before, like here. Where do we have it? Like here, but you can also do this with longer lists, of course. So if you have L1 and you want to concatenate another list, say you have high and 10, we then now have our list L1, which is the exact same thing here. Let's have a look. You can do also, like for strings, you can multiplicate lists. This means that you can say you have a list L1, or this list becomes bigger and bigger. So we can say we concatenate this 2 times again, and now we have this 3 times because it's already there. But to concatenate this 2 times up, we have this once. This expression is 2 times this list, which is a normal list and no variable. But it's again, so we can also do this with this L1. This is a variable and stands for a list, but you can also, let's say we print only L1 out 2 times, so we have this much. But this looks this weird way because we are so much zoomed into this Jupyter Python notebook. Okay, what you can also do is to modify lists with the list member of itself, like here at this point. I'm not sure how our L1 looks like right now. Let's see how this one is. This is 5. Okay, so if you have your L1 and you say, okay, L1 at position 2 is now assigned to L1 at position 2 as well, plus 5. You have your L1 at this position 2, which is 5, and you can use it right there to add 5 to it up, or just you can add what you want, 15 or something else, and it's then assigned to the same place. So our place from L2 is then 20. So we have 5 before, and we summed 15 to it up, so we then have 20. So let's print this list again just to show it the whole list. Where is it? Here. So you have 20 right here, and before it was 5. So you can change things from list. So this is the last slide for today, and I think that's enough when I look at the time. But you can also ask questions well, because I'm a little bit fast right now, I know, but I'm sure you will do this as well. So you can also assign more lists indexes. So if you have at this point, say L1 0 to 2, so the first 2 indexes, and you want to assign another to another values 1 and 5, you then have a 1, and we replaced this high and by with 1 and 5. It's also possible. What you can also do, you can delete some things like this. So if we have then the exact same thing, and we say this is an empty list, and an empty list is obviously nothing, we then have 20, 1, 2, 3, 4. So this sublist, for example, if you want to tell it so, is an empty, and it's gone at this place. You can also, I think this is clear. Yeah, you can also assign a whole list to just one index to insert a list into another list. So you can say, let's just print it out. So at this place with these columns, you say everything in front of this list. And if you then assign it to itself, so the front of this list to itself means that you and then we print it out. Oh, it's too long, but we see it at this place. So this one is our first list. We inserted right here with itself, and this is the old list, but we inserted it at the beginning of this list. So we can also do this at the end if we want to, but we don't have to. The other way around, yeah, we can just delete the whole list if we, or make an empty list out of it if we say this way and make an empty list. So our list is then, I don't want to do this right now. Let's not do this. Let's do with the other. I think we had another list L2, didn't we? So L2 is right now is empty. Because I want to show you, you can use the function length, len, to become the length of a list. So if we want to know how long a list is, how long L1 is, oh, sorry. L1 is this list. I think they're about 10 to 12, 16, wow. Where you can become the length of a list. This becomes a little bit more important if you have if you do not know how long the list is. So if you want to access the last index of a list, say L1, you now know how long you don't know how long it is, and you can simply say length of this list -1. So you then always have your last index at this point. This is 10, and you do not become any errors. Okay, this is it for today. If you have any questions right now, I think you may have enough questions because I was a little bit faster than before. So if you want to, you can now either finish this lecture or you can ask some questions if you want to. I just wait, well, as 2 minutes or so, then you can ask questions if you have one, but I'm pretty sure if you have another question, we have pretty competent tutors and they will answer you every question you have. I'm nearly sure. And if not, you can always ask questions in the forum where we can all look it up, where can other students look it up. And if they have a right answer, this would be fine. Or if we have an answer. So don't be afraid to ask questions into the forum or something else if you have questions, because it becomes more and more complex right now, and it's pretty normal to have questions. Or right now, I can imagine that this was nearly too much to just ask questions. Could make an example of list with names or letters. Could you please pin the flash from about Len? Okay, nice. We have two questions. First, could make another example of list with names or letters. So we have, let's do another list, say, yeah, list. No, we can do this with names and letters. So we can also do a list with only strings and letters. So we can say no Tom, but we can only make just letters in it, writing capital A, writing hello, and so on. So this will name all letters. What we can also do, but we don't have to. We are not. We don't have to only use strings for this list. So we can also write 10, for example, in it, and this would be also fine. This is also okay in a list. This example, if you want to use a for, you can now use for statements and say, okay, for x in our list we did create. We then want to print out every single item out of it, and we become every single item of this list. And if we want to do this in one line, we can now use our space in between, and we have everything in one line. So about if this, so in a for loop, yeah, we have a list is nothing else than a sequence of items in this way. What I meant about the length function is that you that this function you can write it in front of a sequence. For example, our list where we have Tom, A, capital A, hello, and 10, which is 1, 2, 3, 4, 5. So now this gets out 5. So because we have 5 items out of it, but lists are 0 indexed. This means that we start with with index 0. And on the other way around, we have to access the last element of a list with our length -1. Because so we access our list, say this one, Tom, A, capital A, hello, and 10, and we want to access the last, it's called list. We want to access the last element, 10. This is at place 4 because we start with the first element at place 0, and 0 is Tom right here. And because of this, because length gives you the number of items we have inside a list, you can simply say list at at len list -1. So because the length of our list is 5 at this point, so here this is 5 because we have 5 elements in it. But if you want to access the last element of the list, we have to write -1 in front of it because we can only access it with 1 less than the length of the list. So we then become again 10 because the length of the list is 5 -1 then is 4, and so we have again our last element, which is 10. Was this explanation enough? So I guess I'm not sure because of the latency of the live event. I think there's about 15 seconds or something. So if I ask you some questions, I have to wait at least 15 seconds until there comes something back. Yes, okay. Now I received your message. Okay, I would say we are over time. So if you have another question, simply write them into the forum or ask the tutors. So, but thank you very much for your attention. Have a nice week, and don't be afraid about the exercise sheets. They are not too complicated.